Good morning, Mr. Ryan. How are you
Good
this morning?
morning, Miss Sparks. I'm good. How are you?
Great. A little less sleepy than I was yesterday.
Yeah, it was very tiring yesterday.
Mm-hmm. It was. Who knew that having a break could make you that tired?
Oh no, it's crazy.
I know. All right, so let's review completing the square.
Okay.
It's exciting stuff. Um, okay, so what you really want to do on completing the square is you want to actually create that perfect trinomial. That's kind of what you're doing. So you want to create that space on the left-hand side. So you want, you know how a lot of times, like with the quadratic formula, you're trying to get this number over to here. Well, you're actually doing the exact opposite when completing the square. You're trying to get your constant and everything over to the right.
Okay.
So the first thing we're going to do on this problem is subtract 1 from both sides.
All right.
And then that's going to leave us a squared plus 4a equals -3 over here. But we've kind of left our space. I didn't do as good a job as I should have. Over here on this side, we're actually creating space to make a perfect square trinomial. So I'm going to rewrite that a squared plus 4a. That's what I've got left on this side. So this is where I'm going to do that. Half it, square it, add it.
Okay. And by the way, my
Right.
sound's messing up again, so it's coming in like 3 to 5 seconds after I actually say it. So if I don't say something for a while, that's probably just because I don't want to hear myself talking.
I absolutely understand perfectly. And I know that the feedback is that, are you on a headset by chance?
I'm on earbuds, yes, ma'am.
I know that feedback is worse when on earbuds, but I know if you've got siblings and other stuff going on at the house, it's kind of difficult. Am I echoing back as well?
No, ma'am. Here,
Or
I can
just
just
your
go to
own
the other
voice?
room and do it. Here, I'll go to the other room and work on it.
Well, just see if that helps.
All
I was
right.
asking around what caused the feedback because I know that that's a problem.
Wait. Can you hear me now?
I can hear you. Can you hear me okay? And are you getting feedback?
I'm still getting feedback.
Well, there goes that experiment.
Daggum. I wonder what it is.
I don't know. I'll continue asking around about it. But I'll try to do most of the talking since that's a problem. And then just, stop me when you have a question. How's that?
That sounds good to me.
Okay. All right. So I'm creating this space. So now I want to half it, square it, add it. And that's dealing with the b term there. So a half of 4 is 2. And 2 squared is 4. So I'm going to actually add 4 here and add 4 here because whatever I do to one side of the equation, I have to do to the other. So now this is actually a perfect square trinomial, which becomes, when I write it in its factored form, it's actually that half it. The half of 4a was 2. So it's a plus 2 squared. And then -3 plus 4 is a positive 1. And now I want to take the square root of both sides. So that's going to be a plus 2 equals plus or minus 1. And then I'm going to subtract 2 from both sides. And that's going to give me either -3 or -1. Because if I take a +1 and add it to a -2, I get -1. And if I take a -1 and combine it with a -2, I get -3. So my two answers for number 8 are -3 and -1.
Okay. All right, let me try number 9 on my own, and then I'll get the answer and I'll tell you.
Okay, I was going to say on this particular one, when you do this, I'm just going to kind of get you started because it's of course a little funky. So we want to get the 15 over. It's going to give me -10. And now over here, I have this, but I cannot create a perfect square until I've factored out the 2, because one of the caveats to completing the square is the a term, that k squared term, has to have a leading coefficient of 1.
Okay.
So I'm going to have to factor out a 2 all the way across. So once I do that, this then becomes k squared minus 6k equals -5. And now I can complete the square. So why don't you take it from there for just a minute, and I'll give you a minute to go ahead and work through it from that point. Sorry about my phone dinging, by the way.
It's all good.
Okay.
So then I'm good.
I know that the feedback is miserable when that happens. So
it's only feedback for me, so I can only hear myself talking. I couldn't hear you talking one time.
Oh, well, that's good. I'm glad to hear that.
I'm not, because I have to hear
what number are we working on?
We're working on 9.
All right. So I'm just going to go ahead and finish working this out. If 3 squared is 9, so I'm going to add 9 to both sides.
Yeah.
So then the factored form of k squared minus 6k plus 9 is that half it part. So it's k minus 3 squared equals, when I add a positive 9. I'm sorry?
Where'd you get 3 from?
The half it. Remember, half of -6 is -3.
Oh, so you take that half and you put it into the square. The parentheses.
Yeah, that's it. That's the easiest way to think of it, because when you're thinking about creating a perfect square, when you create that square, you're taking half of that -6 and then you're squaring it and then adding it. So this actually right here becomes the perfect square trinomial. That's why they call it completing the square. You're actually completing the square by making it yourself, by taking half of the 6 and then squaring plus 2ab. Yes, can you hear me?
Yeah, sorry, you cut out for a second.
Can you hear me? Okay. Because you're creating that perfect square, because a perfect square trinomial is a squared plus 2ab plus b squared. So that's kind of what you've done here, is creating that. And then when you do the -5 plus 4 plus 9, you get a 4.
Yeah.
Okay, and now we're going to take the square root of both sides. That's going to be plus or minus 2. Then we're going to add 3 to both sides, and that's going to give you k equals 5 or k equals 1.
That's what I got.
Good. Good job. Do you have any other questions on this worksheet?
Numbers 10 through 16.
Okay. So the discriminant, oh, okay. So the quadratic formula and the discriminant.
Yes, ma'am.
Hold on just 1 second, Braden.
Alrighty.
Did anybody else join us?
No, ma'am.
So for the quadratic formula, and you'll notice that I said identify A, B, and C first, because I know for me, that is very, very crucial, because if you don't get that absolutely correct out of the gate, it's, obviously it's very difficult to get the right answer, because the quadratic formula is laden. Yes,
ma'am.
As a matter of fact, I'm going to go ahead and write the quadratic formula up here. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
Well, that's right.
So,
I forgot that.
The very first thing that you're going to do is make sure that this formula is in standard form. And it is not in standard form, so you have to do that first. So on number 10, we've got to get this 6 in over to the other side, and it has to be set to 0. So, and I also want it like in the chronological order, not chronological, but descending order, with the largest degree going first. So that's going to be 3n squared plus 6n minus 13 equals 0. So my A is 3. My B is 6. And my C is negative 13.
Okay, let me go to the other room. Sorry, there's people working at my house.
Oh, I was going to say, man, I think I hear like a drill or something.
Yeah, that's a saw.
Bless your heart. But that's okay. I just want you to be able to hear. You know what I mean?
Yes, ma'am.
All right. So now plugging these values in to the quadratic formula, I would have the opposite of B. So that is going to be negative 6 plus or minus. And then I'm going to have 6 squared minus 4 times A, which is 3, times negative 13, all over 2 times 3. So now negative 6 plus or minus 36, and then negative 4 times 3 times negative 13 is a positive 156. All over 2 times 3 is 6.
Hold on 1 second. Let me get all this worked out.
I'm going to let you get caught up to me.
Okay.
Because then all I did after that, Braden, was just add the 36 and the 156 under the radical sign.
Yes, ma'am.
And that gave me 192. And the reason why I'm letting you definitely get caught up to me is we get the fun part, which I know you love, and I don't want to do this without you, because we get to factor 192.
Wait. Why do you have 30? Oh, no, mine has a plus one.
Yeah, I go real slow, step by step by step.
That's all good. That's the way I'm looking too. Okay, so I'm caught up. And then what you're
So
gonna do is,
now we're going to factor that 192.
Where'd you get the 2 from?
Oh, I just start with the lowest prime number, and that's how I factor.
Okay.
So, and now I'm going to count sets. 2. So that's going to be 2 times 2 times 2. So basically, that's 8. So 8, that tells me that 8 squared. So 64 times 3 should be 192. It is.
Okay.
So that tells me that this answer, negative 6 plus or minus 8 times root 3 over 6. Now, all of this can be reduced. 3 or 2 goes into each one. You can do this one of two ways. But I would stick to just reducing each one of those because it's all divisible by 2. So that would be my final answer.
Okay.
Another way to look at this is if you were looking at it, you could say -1 plus or minus 4/3 root 3. But I'm happy if you get it here. Because remember, this is actually a number. This is a number. And this is a number with the plus or minus in the middle because we're getting 2 answers. Does that make sense?
Yes, ma'am.
Okay, good. But I feel like from a simplicity standpoint, just getting it to here is probably best. Does that make sense?
Yes, ma'am.
I mean, like if you just get it to here, that's great.
Alrighty.
You know, because I think separating it, sometimes I think the book separates the answer. And so that's why I've been trying to do a little bit of that, but I am perfectly fine with, you know, -3 plus or minus, 4 times root 3 all over 3. I'm stoked about that because that's a lot of math if you get to there, right?
Yes, ma'am, it is.
Okay, so let's take a look at number 13. Or no, 11. Do you want me to write that answer back at number 10?
Oh, no, ma'am. I already
Or are you good?
Oh, no, ma'am. I already got it down.
Okay, cool. Once again, the very first thing that you want to do is make sure you get this into standard form. Because you really can't identify those A, B, C values unless it's in standard form. It's just too difficult, and it's going to mess you up right off the bat. You know what I'm saying?
Yes, ma'am.
Oh, that's nice. So this is not in standard form, so I'm going to add 3 in and subtract 104 to get him over here. So then that would be 2n squared plus 3n minus 104 equals 0. So my A is going to be 2. Well, my goodness, Miss Sparks. My B is going to be 3. And my C, oh, this is going to be fun. It's going to be -104. I'm excited about working with 104.
Really? Is that your favorite number now, Miss Bart?
Really? Is that your favorite number now, Miss Bart?
Oh, yeah, that's going to be it.
Alrighty.
All right, so I'm plugging in my values. I've got the opposite of 3 plus or minus 3 squared minus 4 times 2 times -104. All over 2 times 2. So -3 plus or minus the square root of 9 and then 4 times 2 times or a negative 4 times 2 times negative 104 is 832. All over 4. I was kind of and so then that's good. I was kind of hoping that I could get my phone turned the right way so I can use the square root to find out if 841, which I probably should know this. I'm trying to think what is it? Is it, you think it's 29 times 29?
Wouldn't it be 832?
Did we get that lucky? It is.
Because you don't add that, you gotta subtract it.
Praise the Lord. I'm sorry?
I say you gotta subtract it because you don't add 9.
You add.
You don't, or I thought it'd be.
Yeah, you add because you got a positive 9 and then you got negative 4 times 2 times negative 104. So it's going to be a positive 832.
Oh, that's right.
And the only perfect square that I could think of that ended in a 1 was 9 times 9, which is 81. So I was like, okay, well, that could be 29. So, and it is. So we've got negative 3 plus or minus 29 all over 4. So now what we're going to do is we've got negative 3 minus 29, which that's going to be a negative 32 over 4. Or you've got negative 3 plus 29, which is going to be 26 over 4. So you've got 8 or
6.5.
yeah, you've got 8 or 13 over 4. I left mine in fractions. But I mean, either way, obviously is right. It's at 8, I mean, not 8, 13 over 4. It's 13 over 2.
Yes, ma'am.
Well, those were fun.
Sure. Yeah, if you think they're fun.
Do we have any more with the quadratic formula? Or are we going straight into the discriminant? Okay, we're going into the discriminant. Okay. Yeah. All right, now for these, we're only doing, the discriminant is only the radical portion of the quadratic formula, and you don't even really have to use the radical. It's just important to understand that that's where it's coming from, because the answer determines the number of solutions that you would have, whether there's going to be, 2 real, 1 real, or 2 imaginary. And the reason why that would come out that way is if whatever the answer to that part under the radical, if that's negative, obviously that's going to be imaginary, right? Because that's how we get introduced to imaginary numbers, is understanding that -1, or that I, or the imaginary number, is the square root of -1. So once again, very important for it to be in standard form. And the first one is, and then identifying your A, B, and C is still an important part of this. So A is -8, B is a +10, and C is -10. But underneath the radical, we have B squared plus, or I'm sorry, minus 4AC. So we have B squared, which is 10 squared minus 4 times negative 8 times negative 10. So I've got 100. And then I've got negative 4 times negative 8, which is positive 32. And a positive 32 is negative 320. Which is going to give me an answer of negative 220. So if that were underneath the radical, we know that would be an imaginary number, right? Because the square root of a negative number is imaginary. So that tells us that the discriminant is negative 220. So this equation will have two imaginary solutions.
Yes, ma'am.
And now number 13, the A is 1.
Can I try to do this one on my own?
B is 6. Oh, please.
Thank you.
And the C is 9. Not a problem. I'm happy when you guys want to do that. I'll give you a minute.
Alrighty. Is it going to be one real solution?
That's it.
Awesome.
The discriminant is 0 and it's one real solution.
Yes, ma'am. I'm going to go ahead and try 14 as well on my own.
All right. Good job.
And then you get one imaginary solution because 359 is a prime number. Right?
Well, the answer should be a positive 361. Because you have 1 minus,
No,
you have 1 plus 360. Because if you multiply a negative 4 times a positive 10 times a negative 9, you get a positive 360.
Yeah.
You should get 361. And the thing about it is, okay, if it's positive, it's always two real solutions. If it's negative, I mean, if it's positive and not, not like factorable, you know what I mean?
Mm-hmm.
Like it's not a perfect square. You get two real solutions. If it's positive, you get two real solutions. If it's negative, you get two imaginary solutions. And if it's 0 or one whole integer, it's one real solution.
Okay, that makes sense. And then I got number 15 and 16. Let's do...
Okay, because 15, it's completing the square, except you don't go all the way to finding the answers.
Yeah.
You actually leave it when you're putting it in vertex form. You've got n squared minus 4n, and then you're adding that 78 to both sides. It gives you 83. And your half it, square it, add it. So you have n minus 2 squared. Like that?
Yeah.
Okay. And all you're going to do now is do n minus 2 squared. And you're moving this number back over. So you would have minus 92 equals 0 because it has to be set to 0 to get it in vertex form. And the vertex will be at 2, negative 92. Because this is another reason you can complete the square, is to find where the vertex of the parabola is. So basically that parabola is going to be way, way, way down that y-axis.
Yes, ma'am.
Like if 92 were here. You know what I'm saying?
Mm-hmm.
That's another reason that you complete the square. And I just wanted to kind of show you guys that, because that's kind of a throwback to all that parent function stuff.
Yes, ma'am.
And then 16 is just like roots, x-intercepts, and zeros. All right?
Yes, ma'am.
How about these? Are you good on these, or you want some help?
I did have some questions on that one. It was
I was going to say some of these down here, number 23 and 24, those are humdingers.
as well as number 21 and 22.
Yeah.
I got number 23.
I think.
I got number 23.
Oh, you go. That's awesome.
I got 4x to the first power, and then y to 0.
Which technically would just be 1. It actually, the final answer looks like this.
Oh, really?
Mm-hmm. I think 23. Yeah.
Oh, yeah, I did get that, actually.
Okay. It was a hard one though. So
Yeah,
good for you.
It was.
It was hard for me to follow my work on that one. I was like, what was my final answer?
Can we do numbers 21, 22, and 24?
Yes. Okay, so 21, you got a 2, which really can't be reduced with that 3 at all. So you're going to kind of leave that 2 at the top. And the 3 will remain at the bottom. There's no A's to combine, so your A is going to remain on the bottom. The only thing we've got to really deal with is the B4, B to the 4th at the top, and B to the 4th at the bottom, right?
Mm-hmm.
And so when you do 4 minus 4, that's going to give you B to the 0, and anything raised to the 0 power is 1. So you're done.
It's just 2 over A4. Or 3A4.
2 over 3A to the 4th. And that's it.
Oh. Okay. And then
and on this one,
sorry, go ahead.
have a 3 at the bottom, which nothing else gets done with. And then you've got on the top, you've got a negative 3, and there's an assumed 1 on this guy right here. So you've got negative 3 minus 1. So you're going to end with a 4 on the bottom, a negative 4. So that's going to end on the bottom. And then on number 22, you've got y to the negative 1. So that's going to look like minus 1 minus a minus 3. So that equals negative 1 plus 3, which equals 2. So that's going to go back on top as a positive exponent. So it's going to be y squared and then 3x to the 4th.
Alrighty. And then number 24, please.
24?
Yes, ma'am.
All right. So we're going to, we've got -4 times 4. So that's going to give me a at the top. We've got a to the -16 all over. And then down here at the bottom, I've got a 2 times a 2. So that's going to give me 4. And then I've got a with an assumed 1 combined with a 4. So that's 1 plus 4 is 5. And I've got another 1 right here. So that's 6. And then I've got a b to the -4th with a b to the -1. So that's going to give me -5. And then with a b to the 4th. So that's a b. So if I take -5 and combine that with a -4 or a +4, that's going to give me a -1. So my next step is to take -16 up here and combine it with a +6. So that's written -16 minus 6. So that's going to give me a -22. So that guy's going to stay on the bottom with the 4. But this b has a negative exponent and it's in the bottom. So that's going to move him to the top because he wasn't combined with anything there. Oh, whoops, my bad. So he goes to the top.
All right. All right, Miss Sparks. Well, thank you very much for the help. I appreciate it a lot.
Not a problem. You have a blessed day.
You too. Thank you.
See you in class tomorrow. Bye-bye. Hey, Rachel.
Hi.
I've already, how are you?
I'm good. How are you?
Good, thank you. I wanted to make sure that you saw this. I did work through some, and I was thinking about just sending you the recorded one, but I thought, well, maybe if you wanted me to work some with you, it would be easier for you to understand if I was explaining as we went along.
Yeah, that would be helpful if you could do that.
So I don't know if you, yeah. Do you want to do the ones on the review yesterday, or some from the book, or from the coloring activity, or?
It doesn't matter. I haven't started
How do you want
math today yet. So we can do whatever.
Okay. I was going to say, most of the problems that I assigned for today, you're the kind of student that you've probably done all the assignment up into what I handed out yesterday. Because did you complete the coloring activity?
Was that assigned yesterday?
No, ma'am. It was not. It was assigned before fall break. It was the one that I assigned on that Tuesday. Thursday. I apologize. Thursday. Yeah, I was going to say, I can't imagine that you had anything left undone. It's just not who you are. But sometimes people get behind. So, I'm happy to go over whatever. Do you want me to just work through the exponent ones with you, all of them? Or do you want me to just start with the more complicated ones?
If you could do the complicated ones, those are the ones that confuse me.
Okay. So I would definitely say that it starts right around 21.
Okay.
And then they get progressively more complicated after that. So how about if I start there?
That sounds good.
Okay. So what I'm going to do first is kind of look at my constants, and that's my 2 and my 3, and I see that they can't be reduced in any way. So I would just come over here and make my fraction bar and go ahead and write those. The next thing that I notice is that I have an A on the bottom, but not on the top. So there's really not anything to combine there at all. So I'm just going to rewrite my A to the 4th. It will go on the bottom, stays there. And then I've got B to the 4th on top and B to the 4th on bottom, which 4 minus 4 would then give me B to the 0. And anything raised to the 0 power is just 1. So literally my final answer is 2 over 3 A to the 4th. And then on on number 22, I don't have a constant on the top, so my 3 is going to stay at the bottom. And then I've got a negative 3 combined with a positive 1 on the bottom. So that technically looks like negative 3 minus 1. So that's going to give me a negative 4. So when I combine from the top to the bottom and I have a result of a negative, it stays on the bottom with no negative exponent. And now I've got a y to the negative 1 with a y to the negative 3. So that written out looks like negative 1 minus a minus 3, which then is a negative 1 plus 3, which gives me 2. So that's going to be y raised to the 2nd power, and it's positive. So a positive exponent is written at the top.
What if that was a negative? Then would we have it?
It would be at the bottom.
And then we'd have no numerator?
Whenever you're combining, you would have a 1.
Okay.
As the numerator. Good question, though.
I'm sorry, my
Good question.
Echoing and it's tripping me up.
I know. Braden was saying the same thing earlier when he was on earlier and asking questions, and he said the same exact thing. And I think that it's worse with headsets, but we even tested it with no headsets on him. So
I'm
I think it has to do with the proximity of which you're sitting next to your computer. And I don't know. I asked Landon about it and one other student about it who are kind of tech savvy. And they said it had to do with speakers and how close you're sitting. And so, because I know I get feedback sometimes too. It's bad.
Okay.
So your final answer for number 22 is y squared over 3x to the fourth. And then on number 23, we've got 2 times 2. I think we worked this one out in class, but just for the principle of working them out and seeing the process, I'm going to go ahead and work it out again. So at the top, we've got 2 times 2, which is going to be 4. And then we've got an x to the negative fourth and an x to the fourth. So when you add those together, negative 4 plus 4, it's going to give me a 0. And anything raised to the 0 power is 1. So that's going to be x to the 0 is 1, and then y to the 0 is 1. So basically, we've got 4 times 1, which is just 4. And here at the bottom, I've got negative 1 times negative 1, which is a positive 1. So that's going to give me 4 over x.
Okay.
And then on number 24, okay, good. So that on number 24, you've got negative 4 times 4, which that's going to give me a negative 16. And then I'm going to combine the bottom and work this out in 2 steps. 2 times 2, which I have that way over here, that's going to give me 4. And then I've got an a to the first to combine with an a to the fourth. So that's going to be 1 plus 4. That's 5. And then I've got another a down here on the end. So that's going to give me a to the sixth. And then I have b to the negative 4 with a negative 1. So that gives me a negative 5. And negative 5 combined with this 4 at the very end is going to give me b to the negative 1. Now, this is very interesting because this kind of addresses an issue that sometimes can be confusing. Okay, so I don't have any constants at the top, but only at the bottom. So I'm just going to rewrite my 4. Now I've got a negative 16 at the top combined with a negative 6 at the bottom. So that technically looks like negative 16 minus 6, which gives me a negative 22. When you're combining top and bottom and you get a negative answer, you leave it at the bottom with a positive exponent. But do you notice right here on the very end, we don't have anything to combine that b with at the top. There's no b's at the top. So when you have a negative exponent and it's all by itself at the bottom, then that gets moved to the top. When there's no combining going on and it just starts in the bottom, it just goes to the top and has the exponent. So, but since the 1 is understood, you don't write it.
Okay.
So I'm really glad that this one kind of came up because that is, I don't really think of it as an exception, but it is kind of a piece of the rule, you know, of negative exponents. Okay? Does that kind of clarify that a little bit?
I think so. I think I understand a lot better now.
Okay, well, great. All right. Good deal. If you have any more questions, please feel free to email me, okay?
Okay, thank you.
Have a blessed day.
You too.